Hello, everyone. Today we are talking all about measures of center in data sets. If you could please pause your video and try the Ignite at the top. Pause your video now and give it a shot. All right, answers are up. If you look technically for this one, it says make a table of values. All we were looking to do on this one is in place of the X that you see in the problem, we are going to take each one of these X values, -3, 0, 2, and 10, and plug those in for X over here in my equation. So for each of my answers, if I take, for example, -3 times 2 plus 1, -3 times 2 is -6, plus 1, we get -5 as that answer. And we make our way down the table. Now, essentially what we just did is not quite what we're going to be doing today. Today, we're talking all about something called statistics. And simply statistics, if you want to pause your video and write some of these definitions down, statistics is simply just the collecting and organizing and analyzing of data. So this is the unit where we start talking about collecting all of the different types and looking at numbers and kind of thinking about what kind of things can we do with them. So the collecting and organizing is not necessarily something that we're going to focus on too much, but the analyzing is something that we are definitely going to go over. Now, this next word that we see called a variable is not the type of variable that we've been working with really up till now. Variable up till now has meant something that's unknown. In statistics, what a variable means, it just means it's any characteristic, number, or quantity that can be counted or measured. So like when you look down here at our first example, it says the different types of data. When we see this word quantitative, the first part of this word actually has the word quantity in it. And that just means that this is something that's measurable and actually has a number-based answer. So if we look at this rows and we want to talk about things that are measurable or things that have number sort of answers, one of the categories of quantitative data would be something along the lines of the number of petals. That is something that we can go about counting about this rows. Now, there's a whole lot of different categories we could go to. One of the other ones we could do, for example, we could say number of leaves. We could count the number of leaves that this rose has. We could also potentially talk about the height of this rose. The height of this rose is also a number answer for this piece of data. Now, quantitative data isn't the only type that we can work with. There's also something called qualitative. And this more is just like categories. The categories of, for this example, the rows that we could look at. One of those being, we could talk about the different types of roses. We could also look at the different colors of all the roses that are out there, pink, red, white, all of those different ones. But those are what we call qualitative. In statistics, we are mainly going to work with more quantitative data than anything else, but there are some cases where qualitative data kind of factors into that as well. Now, ultimately, statistics is on analyzing, but it's also about calculating different, obviously, statistics. And one of the most common ones that we look at is something called measures of center. A lot of times when you look at a data set, one of the things that we try and find is the middle of a data set. Now, what it technically does is it measures, what is average in a quantitative data set. So if we look at all of the numbers that are provided, the middle is, we can actually calculate a couple different ways. And the three measures of center here, the three things that we can calculate are called the mean, median, and mode. The mean is the sum of all the numbers divided by how many numbers. The median is the number that is halfway through the set. And the mode is the number that occurs the most. Now, one of the other calculations that we're going to do is also something that's called the range. And the range is just a different it's a different statistic that looks at the difference between the greatest and lowest values. So in statistics, there's way more calculations out there that we can do other than these four. But these are the main ones that we're going to really calculate about a data set. So if we turn to the next page, the first example that we're going to look at is example 1. And this one says the table shows the number of hits Marcus made for his baseball team. Now you're going to notice that in statistics, there's a lot of different ways to kind of organize the data. Organizing the data is kind of like the step before analyzing a lot of it. So one of the ways you're going to see it analyzed or organized, I should say, is in a table like this. You guys don't have to turn in your notes yet, but if you look even towards the homework for today, you're going to see that, for example, sometimes it lists them as a list like this. Sometimes it does a table that's multiple rows, or just obviously a table like you see down below. All of those cases are different ways that they can organize your data. But it doesn't change the fact that our goal is going to be to find these three things. We want to find the mean, the median, the mode. And then we also are going to go about calculating the range. Now, my range on this one is actually one of the easier things to do. The range is the difference between the highest and the lowest values. So if I was going to calculate my range, we would take the highest number of hits that Marcus had in one of his baseball games, which was 7. And we would subtract it by the smallest number of hits that he had, which it looks like it was against the Vikings and he had 0 hits. So we would take 7 minus 0, and that would tell me what my range of this data set is. And what the range really tells us is it just tells us basically what the span of the numbers is that we're working with. From 0 to 7, there's 7 numbers in there that we basically cover. Now, it doesn't mean that we have all of those numbers in there. It just means that your numbers span that distance. Now, if we're going to go about calculating the center of this data set, we're going to calculate the 3 measures of center here: the mean, the median, and the mode. Now, the first one I always kind of like to start with is the mode, because it is one of the easiest ones to calculate and that there's no calculating. It's the data point that occurs the most. So if we look here, I'm looking at this and the data point that I see that occurs twice is 3 hits. All of my other data points, 6, 5, 0, and 7, all only occur in 1 game. But he has 2 games where he had 3 hits. So my mode, we would say, is 3 hits. Whoa. Now, the mode is kind of an odd calculation. It's probably the one that's the least accurate, because just because something occurs the most doesn't necessarily mean it's like the true mode. But there are certain data sets where the mode actually is a valid measure of finding the center. Now, when we find the other 2, we have a different process for finding these other 2. The first one we're going to actually go about calculating is the mean. And the mean is when we take all of our data points and we add them together and we divide by how many data points we have or how many games he had hits in. So we're going to do that here. We're going to take all of our games. I'm going to take 3 plus 6 plus 5 plus 0 plus 3 plus 7, all 6 of his games, and we're going to add them together and we're going to divide by how many hits he actually had, or how many games he played in, which was 6. Now, when I add all those together, if I take 3 plus 6 plus 5 plus 0 plus 3 plus 7, all of those added together ends up being 24, which I am then going to go about dividing by 6. And that's going to give me my mean, which is 4 hits. So the average amount of hits that he has in any given game is about 4. Now, obviously the range is 7. So the range is anywhere out a little bit outside of that, all the way from 0 to 7. But the average number that he has is about 4 hits. And the last one that we can calculate is what's called the median. Now, the median has a special case, and that means we have to order this. If the median the goal is to find the middle of the data set, the exact center of all of your data points, we have to make sure that it's in order. So if I order all my hits, let's see, I think we have 0. Whoops. I have 0 is the lowest. Then the next lowest is 3, then 5, then 6, then 7. And what we're going to do basically is we're going to kind of work our way through the middle here. Now, one process, some students like to kind of cross off one on each end. Some will kind of cover up one as you work your way in, but you want to make sure you go evenly. If I cross one off on this side and one on the other, we want to work our way into the middle Now, this one is a little bit odd in that we do have a tie. And this happens anytime we have an even number of data points, because the median here is the number that's halfway in between however many numbers we have. So because we have six data points, the middlemost number is halfway in between the three of them. Now, when we go about finding the very middle, if we have a tie like this, what we do is we do what's kind of like a mini mean. We are going to average those two data points together. We're going to add them two together, divide by 2. And what that's going to give us is our median, which is 4 hits. Now, your mean and your median like this will not always end up being the same, although it is possible in a lot of cases. But for our purposes, it just means in this case, it just so happens that my mean and my median were the same. Now, the last thing we're going to go, part B says, suppose Marcus didn't play the last team. Now, one thing that we can kind of start to figure out is that if he doesn't play the Panthers, that's going to change a lot of things about my middle and my range. First of all, if we're going to recalculate my range, the goal is to take the highest minus the lowest. If that game isn't there, if there is no Panthers, then my highest isn't 7 hits anymore. If I take the highest, which is 6, the lowest is still 0, that still leads me to my range that is 6. So but there's one less hit that we ultimately span when we actually take out that last game. But it also is going to change some of our other statistics. If I'm going to start by finding my mode, now my mode is actually the one that's kind of unaffected because we still have over here, there's 2 points on here that has a hits of 3. And that still occurs more than all of the other data points. But it does change what my mean and my median are going to be. If I'm going to calculate my mean, calculating the mean now has a couple different changes. That last game that's there isn't actually there anymore. So we're still going to add up all of the other pieces here, but it also means that we don't have 6 games anymore. If I take that 6th game out, there's actually only 5 that are left. So if I add all those up and then divide by 5, that's going to leave me with my mean that is about 3.4 hits. Now, I know that's a decimal. We're not saying that this is a real life scenario because can you have 0.4 of a hit? No. But it does mean the average number of hits, though, goes down. And that's something that we can kind of predict. If we take out the highest numbered game, then that is going to go about decrease. If I take out the highest number of hits that he had, then that is going to kind of change and lower everything else. So it makes sense that my mean in this case went down. Now my median, this is one where we can't necessarily tell by looking at until we actually go about finding it. Now my median, we still stay with it being ordered, but it does mean that we don't include that last game of 7. So if we work our way in here, now here we don't have a tie. If I take 2 off of either end, we actually do have a true median in this case, which is just 3 hits. So when you take out that highest value, you notice that your mean and your median most likely are going to go down. If you take out the lowest value, then that's going to raise everything at the end of the day. Now, when we calculate our mean and median, there's a lot of other things that we can do with those pieces. And one of the things is actually going to be our example number 2. And this one says we have an antique dealer that purchased 5 antiques. The average price of these 5 antiques was $170. Now let's think about this word average. When we see this word average, we want to start thinking which measure of center is it asking us to work with. Average is always talking about the mean. So let's kind of pay attention to ultimately what the mean is doing. What the mean does ultimately is it takes the total of everything that is of anything that's being analyzed. It's divided by the number of data points that we have. And ultimately what that's calculating is the mean. Now, the cool thing about this process is we don't have to use this process to find the mean. In this case, it actually tells us what the mean is. It says the average or mean price of these 5 antiques was $170. So if I know my mean is 170, then what this also allows us to do is find the total that's there. I don't actually know what the total is. That's what it's asking me to find in this problem. But I do know how many numbers were totaled. They had to have added all 5 of the different prices of the antiques divided by 5, and they got 170 as the answer. So we can also use this to kind of work our way backwards. If I multiply both sides by 5, 170 times 5 is going to tell me what the total amount of all of those antiques were, which 170 times 5 is 850. And that is the total price of what we spent. Now, the downside is that we don't know what the individual prices of those 5 antiques are, but I don't actually really need to know that. I just know that the total of all 5 of the antiques was $850. Now, part B, though, says we're going to add on to this. It says he later bought another antique for $758. What is the mean cost of all antiques? So in this one, we're still using our general setup here. It's just that here is where we're actually going to calculate the mean. But we have to think about how that calculation would happen. The top part of the mean has to be the total amount that was spent on all of the antiques. And we don't just have 5 anymore. We have the 5 from the beginning plus the one that we just found, which means we also have to add those totals. The totals for all 5 of the first ones were 850. And it's adding in the last antique, the 6th antique, was $758. So if we're going to go about calculating our mean, we're going to start by adding those guys together. If I take 850 plus 758, that's going to be 1,608. And then to find my total mean, we're going to go about dividing by 6. And that's going to give me my final answer of $268. Now, one thing that I can tell from this is that if we compare the means, the mean of the first one was 170. The new mean is $268. Since my mean raised, one thing that I know for a fact is that this antique was more than all the other antiques individually. If the average is 268, but it used to be 170, that means we raised the general mean price of everything, which means all the other antiques had to be cheaper than this one really was. Now, if you guys want to pause your video and try the 2 you try nows at the bottom, for the first one, I want you to find the mean, median, and mode. And then number 2, answer and tell me what are the 3 measures of center. Pause your video now if you want to see what the answers are. All right, answers are up. If you did not get these guys, make sure you check with your teacher to see what went wrong. But now you guys can move on and you guys can start working on the homework for the day.